friends are going out to dinner. There are 3 tables available to sit around. The tables seat 3, 3, and 4 people respectively. In how many ways can the friends be sat around the tables for dinner? Okay, so we got 10 people, but they can't all be together. We've got to break them up into smaller groups and send them to the various tables. Well, we know how to break a large group into smaller groups. That's multinomial notation. Okay, so you might say step 1, break into groups. Okay, we got 10 people. Choose 3 of them to go to one table, 3 of them go to another table, and 4 will end up at the big table of size 4. Okay. But while we just use multinomials, we split into groups. We've got 2 groups of the same size. Can I really tell them apart? We don't have any extra identifying information. Okay, there's no way to tell the 2 tables apart. It's not like one is a wooden table and one is a metal table. It's not like the question described one of the tables being closer to the window or one of the tables being closer to the kitchen, one of the tables having a red cloth or anything like that. These 2 groups of 3 cannot be told apart. So what can we do here? Well, we have to correct our counting because we have indistinguishable groups. Okay, so 2 groups cannot be told apart. They're both a size 3, and they're both going to sit at a table, and we can't really tell which table. Okay, so 1 over 2 factorial. We divide by 2 factorial in order to correct for the fact that there are 2 groups that are indistinguishable to us. Now, with that done, with them actually splitting into the different groups completed, we can finish what we started. We can actually seat them around the tables. Okay, so we'll have them sit down. Okay. Now, one of the groups of 3 has to sit at a table of 3. There's 3 minus 1 or 2 factorial ways to do that. There's 2 factorial ways for the other group of 3 to sit down at their table. Okay. 4 minus 1 factorial is the number of ways to seat 4 people around a table. So that's 3 factorial. And since this has been a series of choices, okay, we can multiply it all together to get our final answer. So 1 over 2 factorial, 10, choose 3, choose 3, choose 4, times 2 factorial, times 2 factorial, times 3 factorial. So the number of ways to split them up and have them sit at different tables. Okay. Now, leaving the answer like this is good. It shows that you understand the indistinguishable labels and the different circular permutations, but obviously there's a temptation to cancel out some of the 2 factorials. And you know what? 2 factorial is 2, 3 factorial is 6. These are small values we should know. So we could say the answer is just 12 times 10, choose 3, choose 3, choose 4. Now that's a simplified answer, but it does sort of hide some of the work we did. It's not as apparent that we understood how everything fell into place. Okay, but still perfectly valid. Same numerical answer, just different notation, really.